Welcome. Have you ever wondered how you can type google.com into your phone and, like magic, connect to a server that might be hundreds of miles away? Well, it's all thanks to a system of unique addresses. And today, we're going to crack the code on how they work. This is stuff you absolutely need to know for your Cisco and Pearson IT exams, so let's dive right in.
To really get this, we're going to follow one little piece of information on its journey. We'll start right from your computer, see how it gets through your home network, and then follow it out onto the huge global internet. By the end, you'll see how all these pieces click together, which is exactly what you need to know for your certification.
All right, so our journey starts right where you are, on your local network. It doesn't matter if it's your Wi-Fi at home, your school's computer lab, or the network at work. Every single connection to the internet begins right here.
You know, if you've ever had to mess around with your home Wi-Fi settings, you've probably seen this number. And it's not a coincidence. This super common address is actually a huge clue about how networks are put together, and it's the perfect place for us to start.
Here's the best way to think about it. Your computer's address on your home network is called a private IP address. It's kind of like your apartment number. Let's say it's apartment 101. Inside your building, that's all anyone needs to find you. But if someone from another city wants to send you a letter, they need the building's main street address. That's the public IP address, and there can only be one of them in the entire world.
So, it turns out these private addresses aren't just random. There's a rulebook for the internet called RFC 1918 that sets aside these three specific blocks of numbers just for private networks. That's why so many of us have that 192.168 address at home. Now, for your exam, you've got to memorize these three ranges. Seriously, knowing these by heart is a huge advantage. Okay, so that leads to a really big question, right? If all our computers have these private apartment number addresses, how in the world do they send and receive mail from the global internet? It feels like we're missing a step. And this image, well, it shows the problem perfectly. You've got three totally separate networks, and guess what? They could all be using the exact same private addresses inside. You can't use those on the public internet because they're not unique. So right at the edge of the network, we need some kind of translator.
And that translator, it's a process called network address translation. You'll usually just hear it called NAT. This is honestly one of the smartest and most important ideas in all of networking. And the device that does all this magic work for you? Your router.
So let's go back to our mailroom idea. Your router is the mailroom. Your computer sends out its data, the letter, with the return address of apartment 101. Your router grabs that letter, crosses out apartment 101, and writes the building's main street address on it instead before sending it out. Then, when a reply comes back to the main street address, the router remembers, oh yeah, this one is for apartment 101, and makes sure it gets to you.
So why are we spending so much time on this one idea? Because NAT is absolutely fundamental. You won't just see this on your Network Plus exam. If you decide to go into cloud computing with AWS or Azure, you'll be working with something called a NAT gateway. And guess what? It does the exact same thing. It lets a whole bunch of private servers in your secure cloud network talk to the internet using just one public address. If you master this now, you're already giving yourself a major head start for the future.
Okay, so we've got a handle on how a small home network can talk to the entire world. But what about really big networks? Think about a college campus or a huge company with thousands of computers. How do they keep all of that organized and running fast? Well, that's where something called subnetting comes in. Imagine trying to deliver mail in a giant city where the houses only had numbers, but no street names or postal codes. It would be an absolute nightmare, right? Total chaos. Subnetting is the clever way we create those digital postal codes. It lets us break one giant noisy network into smaller, easier to manage, and much, much quieter pieces.
Here's the key thing you have to get. Every single IPv4 address is actually doing two jobs at the same time. Part of the address tells you what network it's on. Think of that as the street name. The other part points to the specific computer on that network. That's the house number. You need both to get data to the right place.
So how does a computer know which part of the address is the street name and which part is the house number? It uses this special number called a subnet mask. The easiest way to picture it is like a stencil. You lay this stencil over the IP address, and it shows you which part is the network and which part is the device. It's the official dividing line. Now, typing out a long number like 255.255.255.0 over and over again is, well, it's a pain.
So network engineers came up with this really handy shortcut called CIDR notation. Most people just call it slash notation. All you do is count the number of ones in the subnet mask. In this case, there are 24 of them, and you just write it after a slash. It's way faster, and trust me, you are going to see this everywhere.
Okay, so sometimes a device needs to send a message to everybody on its local network all at once. We call this a broadcast. It's basically like shouting in a big open room. The area where that shout can be heard, that's called the broadcast domain. And routers, well, they act like walls between rooms. They stop the shouting from spreading all over the place.
And this right here, this is the whole reason we do subnetting. On the left, we've got a network for 200 people. On the right, another 200 people. Because there's a router between them, if someone on LAN 1 sends a broadcast, if they shout, it doesn't bother anyone on LAN 2. By making these smaller broadcast domains, we cut down on the noise and make the whole network faster and more efficient for everyone.
So everything we've talked about so far has been about the original Internet Address System, IPv4. But way back in the 90s, when the Internet started getting really popular, engineers saw a massive problem coming. We were literally going to run out of addresses. So they had to invent a whole new system for the future.
The solution they came up with is called IPv6, and the number of addresses it provides is, well, just look at that. That is not a typo. It's a number so big it's hard to even wrap your head around.
To try and give you an idea of just how big that number is, the old IPv4 system had about 4 billion addresses. This number, 340 undecillion, is big enough to give a unique IP address to every single grain of sand on the entire planet. So yeah, we are not going to run out of these.
So what are the main differences you need to know? First, it's way, way bigger, 128 bits instead of 32. Second, the addresses look pretty different because they use hexadecimal numbers, which includes the letters A through F. But here's the most important point for your exams. IPv6 does not use a subnet mask. It only uses that slash notation, which we call a prefix length, to mark the network part of the address. That is a huge change. Okay, you've seen the concepts, you've learned the new words, you've heard the analogies. Now, let's put it all together. We're going to apply this to the kinds of questions you can pretty much expect to see on your certification exam. Okay, here's our first one. Take a second and look at these 4 options. Think back to that table we saw, the one with the 3 special ranges for private addresses. Which one of these fits?
If you picked C, 192.168.50.10, you are absolutely right. That fits perfectly in the Class C private range. Now, A is a famous public address for Google, so that's out. D is also public. The really tricky one is B. It starts with 172, so it looks right. But remember, the private range is only from 172.16 through 172.31. This one is 32, so it's just outside the line. That's a classic exam trick, so you'll gotta watch out for it.
All right, next question. You've got one public address, but 20 computers all need to get online. How can they all share that one address? Think back to our magic mailroom analogy. What was that special process that translated all those private addresses into one public one? And the answer is D, NAT. This is the exact job that NAT was invented for. Now, A, DHCP, is what gives those 20 computers their private addresses to begin with, but it doesn't connect them to the internet. B, DNS, turns names like google.com into IP addresses, and C, subnetting, is for breaking up a network, not sharing one address.
So when it all comes down to it, you need to be really comfortable with these key terms. This is the basic language of networking. If you can explain what each of these means, you're going to be in fantastic shape for your exams.
And you know, that's the really cool part. This isn't just about passing a test. The next time you watch a video or look at a website, you could actually appreciate the incredible, high-speed journey that your data is taking. You now understand the language of the internet. And that leads to one final thought. This journey your data takes is complicated, and at every single step, security is a big deal. As you keep studying and start getting ready for certifications like Security Plus, think about where the weak spots are and how we protect them. Thanks for joining me.